Right. So the title of this lesson is Proving Geometric Relationships. So we're going to do some more proofs, or we're going to use things that we've proven. And to do that, we need to go over some more theorems. First one, 2.3, right angles, congruence theorem. Might seem like common sense here, but a theorem, something that's proven, and then we can thus use in proofs. Right angles, congruence theorem says that all right angles are congruent. So think about that. If it's a right angle, it measures 90 degrees. So any right angle is going to measure 90 degrees. And so thus all right angles are going to be congruent. Check out this visual here. How many right angles do you see? All right, the next theorem, congruent supplements theorem. We've gone over supplementary angles, two angles whose sum is 180 degrees. So I want you to think straight line. What two angles will create that straight line? The congruent supplements theorem says if two angles are supplementary to the same angle or to congruent angles, then they are congruent. It's kind of like that transitive property there. In the image here, see that if angle 1 and angle 2, they're supplementary, they add to 180. And angle 3 and angle 2 are also supplementary, they add to 180. Then you can make that jump that angle 1 is congruent to angle 3. And you can see this in the GeoGebra applet here as well. Angle A and angle B are supplementary. Angle A and angle C are supplementary. And angle A is going to be angle A. It's congruent to itself. So they're congruent. We had the congruent supplements theorem. Of course, we have the congruent complements theorem too. If two angles are complementary to the same angle or congruent angles, then they are congruent. So in this image here, remember two angles that are complementary add to 90 degrees. So we're going to add just like to 90 in this case, not supplementary, not a straight line, but just 90. If angle 4 and angle 5 are complementary, so they add up to 90, and 6 and 5 are also complementary, they add to 90, then you can conclude that angle 4 and 6 are congruent. And you can kind of see that here in the applet as well, or angle A. Those angles are the same. So no matter how we slide it, those two angles are the same if the two angles are complementary. They will equal. This one's important. The linear pair postulate. If two angles form a linear pair, then they are mixed straight line. They're supplementary. So angle 1 and angle 2 form a linear pair. So angle 1 and angle 2 are supplementary, which means the measure of angle 1 plus the measure of angle 2 is 180 degrees. We're going to put a big box around this because it's very important. And we're going to work on some GeoGebra applets in class to show this. And the theorem that will come up over and over and over again, so it's really important you know this one. 2.6, the vertical angles congruence theorem states that vertical angles are always going to be congruent. So just a reminder, vertical angles, those two angles that share a common vertex, they're across from each other. They make V's with each other. They're always going to be congruent. So in this image here, angle 1 and angle 3, those two angles, they make V's with each other. They share that common vertex, and they're vertical angles. And 2 and 4, they also are congruent angles. And so they're vertical angles. And there was an important point that was brought up in live class that I thought was actually really interesting. And so I don't want you to get confused vertical angles with vertical lines. And so a quick little look up here, I found that vertical angles are called vertical because the term refers to the shared vertex point where two intersecting lines meet, not the usual meaning of up and down. So it actually has nothing to do with the vertical line up and down. Okay, so erase that from your memory when you're thinking of vertical angles. It just has to do with that common vertex, not vertical lines. Essentially, vertical in this context means related to the vertex where the lines cross. Class, we're going to do a quick fun GeoGebra activity. So when you click on that link, you do not have to sign in. You can just put your name here to join. So and then you just click continue without signing in. And so we're going to work on this in live class, but I just wanted to show you a couple of the cool applets that we're going to fiddle around with. It does take a minute to load, and there are some tasks to answer, but this is the main applet, and it's just showing our vertical angles here. We have vertical angles pair 1, pair 2. You can move them around and you can kind of make conjectures. Those are vertical angles. And then we also have linear pairs, and you can move those around to make those conjectures. So spend some time doing that before class if you would like. So we are going to work on this together in live class. And last but not least, we have some example problems. So I'm just going to demonstrate on your note-taking template. So remember, you can print this out, save it however you wish. 2.6, proving geometric relationships. These notes were filled in, and then your examples are down here on the second page. So our first example, we have 2.6 exercise number 4. It says use the diagram and the given angle measure to find the other 3 angle measures. So I'm going to get my drawing tablet out here. We know that the vertical angles are going to be congruent, and we also know a linear pair. So it is given here that the measure of angle 1 is 117 degrees. That's pretty important. We're going to need to use that. So let's go ahead and label that. Measure of angle 1 is 117 degrees. So actually, when you have 2 intersecting lines and you know one angle, you can find all the angles. We know that the vertical angles are congruent, and so angle 1 and angle 3 are directly across from each other. They're vertical, so they're going to be congruent. So this angle here is also going to be 117 degrees. We also have a set of linear pairs. So remember, a straight line, you can always assume a straight line. We have some straight lines here. So this straight line created by angle 2 and angle 3, straight line measures 180 degrees. So I'm going to do 180 degrees minus that 117 degrees in order to get what angle 2 is. So quick calculator here. 180 minus 117 is 63 degrees. So this angle 2 is 63 degrees, and then those 2 angles are vertical, or you could use the fact that 4 and 3 are a linear pair, and also 63 degrees. So measure of angle 2 was 63 degrees, measure of angle 3, 117 degrees, and angle 4, 63 degrees. So something also to notice, if you have these 2 lines that are intersecting here, if you start here and you go all the way around, what's a whole circle? A whole circle is 360 degrees. So you should be able to add all those up, and they should equal 360 always if you did the problem correctly. And our next problem, 2.6, number 7, we got to throw some algebra in, right? Okay, so find the value of W. Well, looking here, what kind of angles are labeled? We have this angle right here that's 5W plus 3, and this angle directly across from it that's 98. Those 2 are vertical angles. So it's given that way for a reason. It helps you determine what sort of algebraic equation you're going to set up. Do we add them and set them equal to 180? Okay, that's true, right? No, wait, those are vertical angles. What is true about vertical angles? Vertical angles are congruent. They're the same. They're equal. So these 2 angles should be equal to each other. So we'll set up an equation so they're equal. 5W plus 3 equals 98, and we're going to solve it. So subtract 3 from both sides. And W is going to equal 95 divided by 5, 19. And this one doesn't even want you to plug it in, just wants W, 19. But we could plug it in for fun here. Let's see that we did it right. 5 times W, which is 19. What should it equal? Plus 3. So 5 times, that's 95, is 98. And look at that. This angle would then be 98 degrees. Those 2 are vertical. They're congruent, so it worked. Love it when it works. And last but not least, more algebra. Goodness, don't get scared. We can do this. Promise. It's good to be doing these example problems together because you'll probably have some problems very similar in your checkpoint and your assignment. So what can we set up here? There's kind of a lot of things that we could set up. First off, what I'm looking at here is we have a straight line, okay? So we have this straight line here, and so we know that two angles that create a straight line are supplementary, so they add to 180. So we could say this angle plus this angle, add them together, and we get 180. But what's the problem with that? Okay, we would have 3b plus 7a plus 33 equals 180, and we could solve it. But can we solve it? No, we have two variables. So we don't want to use that right now. What would be some options where we could have the same variables? Well, we do know, let's just use this one, 3b. This angle 3b is vertical with this angle here, 6b minus 42. Vertical angles are congruent. We can set those equal. We also know that this top angle here, 7a plus 33, is congruent to this bottom angle, 10a minus 12, because they're vertical angles. So we can set up some equations. So let's go ahead and start with the blue ones that I noted there. So the 3b and the 6b minus 42, vertical angles with each other. So you're going to set them up so that they're equal. So 6b minus 42 equals 3b. Okay, vertical angles are congruent, set the equations equal. To solve this, I'm going to go ahead and subtract 6b from both sides. So then I have negative 42 equals negative, oops, not 6, negative 3b. Divide both sides by negative 3. And 42 divided by 3 14. So 14 is B. And I guess it just wants the B, so it doesn't want you to plug it in. So we have 14 here. We could plug that in. And then if we did plug that in, so for instance, 3 times 14 is 42. We know that this angle is 42 degrees. This angle is 42 degrees. We could then use that linear pair. We could say 7a plus 33 plus 42 is 180. All sorts of different options here, but let's just stick with the vertical angles because I feel like we're getting pretty good at that one here. So our next equation then to find a, we could use the fact that 7a plus 33 is going to equal the vertical angle with that one, 10a minus 12. I'm going to go ahead. In this case, I'm going to add 12 to both sides first because I don't like negatives. So then I have 7a plus 45 equals 10a. Subtract 7a from both sides. Again, print this out and do these by hand, also following along, pausing. Then you have your notes handy for you when you're taking your assignment and your checkpoint. Okay, so we got 45 equals 3a. We're going to divide both sides by 3. And yes, I need a calculator for that because I'm hungry. 45 divided by 3, 15. Should know that one. So a equals 15. You can use that symmetric property and flip them. So a is 15, and that's all actually we wanted here was that a was 15. We could plug that in if we want, though. 15 times 10, 150 minus 12. 150 minus 12 is 138, and you'll see these are both 138 degrees. We do have their linear pairs, 138 plus 42. That makes 180. That worked. Same thing. And together, all of them make 360. So all sorts of great things happening here. More examples to come in live class. Don't you worry.